During steady-state exercise, the dilation of blood vessels feeding the working muscles act to reduce blood pressure, but this is counteracted by the increase in blood pressure caused by cardiac output. When exercising, it also raises our systolic pressure, but there is only a slight change in our diastolic pressure. Immediately after exercising, there is a fall in systolic pressure. This is because our skeletal muscles pump is no longer pumping blood from the muscles to the heart. This can lead to blood pooling in the muscles and cause an athlete to faint, as there is not enough blood being pumped to the brain and around the body. The amount of energy needed is suited to the amount of oxygen which is taken in to burn food. This means that there is no oxygen shortfall during the exercise that is being taken place. For example, jogging and walking isn't necessarily easy to maintain a certain level of exercise for a long period of time, as it can cause an injury. The cardiovascular system consists of the heart, the blood vessels, through which the heart pumps blood around the body. During exercise, our heart rates needs to increase in order to ensure that working muscles receive adequate amounts of nutrition and oxygen. Before we start to exercise, there is an increase in our heart rate. This is known as the anticipatory rise, which occurs because when you think about exercising, it stimulates the sympathetic nerves to release adrenaline. Once exercise has started, there is an increase in carbon dioxide and lactic acid in the body. This then further increases our heart rate. During exercise, our cardiac output also increases. This is the amount of blood pumped from the heart every minute. It is also known as the product of heart rate and stroke volume. Because exercise has the effect of increasing heart rate and also increasing cardiac output, it effectively then increases blood pressure. If cardiac output is an increase and the resistance to blood flow does not change, then blood pressure will automatically increase. This is because the altering of blood flow can change the effects of blood pressure. This is done by involuntary smooth muscles in the arterioles, relaxing or contracting. There are two main types of exercise that causes our cardiovascular system to change. Aerobic exercises use oxygen in the process of supplying energy to the body. These types of exercises are known as low intensity levels. Examples of aerobic exercises are walking, jogging, cycling and swimming. The other type of exercise is anaerobic exercises. These do not use oxygen in the process of supplying energy to the body when exercising. They are also known as high-intensity exercises. Examples of these are sprinting, high jump, and speed swimming. As exercise continues, the heart rate will level off. This also happens with the blood pressure as well. While exercising, there is an increase in venous return. This increased volume of blood has the effect of stretching the cardiac muscles to a greater degree than normal. This stretching has the effect of making the heart contract much more forcefully and thereby pumping out more blood during each contraction, so stroke volume is increased during exercise. This effect is known as Starling's law. On average, the cardiac output is around 5 litres per minute. However, during exercise, the working muscles need a greater proportion of blood in order to supply them with energy. The body is able to redirect blood flow by constricting the blood vessels, leading to organs that do not require such large blood flow. The respiratory system's responses to exercise. Firstly, we have pulmonary ventilation and breathing rate, the amount of air we breathe in and out per minute. This increases as we start to exercise. This is because when you start to exercise, you need to take more oxygen into your body for it to be able to use and produce energy. At the start of exercise, this increased oxygen demand occurs by breathing at a faster rate and breathing in more air and breathing out more air during each breath. This is known as the tidal volume increase. We also need our intercostal muscles to help us with breathing when exercising. During anaerobic exercises, it is not uncommon for people to perform the Valsalva manoeuvre. This is when someone is breathing against a closed mouth or nose. After having peaked in the first few minutes of exercise, it remains at the same intensity, tidal volume and breathing level off and remain the same until the exercise has terminated. Also, when exercising, oxygen is released by hemoglobin in places where there is little oxygen, such as exercising muscles. During the duration of exercise, the tidal volume will level off and so will the breathing rate levels. Neuromuscular responses. When we exercise, especially when we want to exert high levels of force, our motor units produce muscle contraction at different rates. Therefore, you will find that different parts of the muscles are contracting at slightly different times. This is an effect of producing smooth muscle contractions. When we exercise, our neuromuscular system has to work a lot harder in order to send the messages from our central nervous system to the muscles, in order for them to contract a lot faster. The neuromuscular junction is the place at which the nerves and the muscles meet. Once the muscle has carried out its desired movement, the enzymes break down the acetylcholine to leave the muscles ready to receive its next signal. The way in which muscles detect when the muscle is in a state of contraction is through the muscle spindles. During exercise, there is an increased pliability of muscles and an increased speed of neutral transmissions. The reasons for why the muscles become more pliable is because as more blood is pumped through the muscles and excess heat is generated through exercising, muscle tissue warms up. The warmer the muscle tissue becomes, the more pliable it is. When exercising, it is important to know that high level intensity exercise for a long period of time can eventually interfere with calcium release, which is required for muscle contraction. If no calcium ions are available, the muscle is unavailable to contract. Eventually, transmissions of nerve impulses can be affected by this. Energy systems response. The aerobic energy system provides ATP at a slower rate than the other two systems. The phosphate system is the energy system that supplies the majority of ATP. It also supplies ATP much quicker than the other energy systems. It produces ATP in the absence of oxygen. This makes it an anaerobic energy system. The phys system is made up of phosphate and creatine molecules. When the bond between phosphate and the creatine is broken, energy is released, which is then used to make the bond between ADP and phosphate. phys stores are used for rapid, high-intensity contractions such as in sprinting or jumping. These stores only last for about 10 seconds. Once our phys stores have run out, we use the lactic acid system. This is known as anaerobic glycolysis, which literally means the breakdown of glucose in the absence of oxygen. When there is no oxygen present, the pyruvate is converted into lactic acid. This system produces ATP very quickly, but not as quickly as the phys system. Although the lactic acid system produces a majority of ATP, during high-intensity exercise. This is because it lasts between 30 seconds and 3 minutes. Lastly, the aerobic energy system, as we have already said, it provides ATP a lot slower than the other systems. This is because it is responsible for producing the majority of our energy while our bodies are at rest or taking part in low-intensity exercises such as jogging or walking. It uses aerobic glycolysis as a reaction, as it occurs when oxygen is available to break down glucose. As in the anaerobic energy system, glucose is broken down into pyruvate. Because oxygen is present, pyruvate is not turned into lactic acid, but continues to broken down through a series of chemical reactions which include the Krebs cycle and the electron transport chain. They both take place in organelles. The Krebs cycle is pyruvate from aerobic glycolysis combined with coenzymes, which reacts with a number of different compounds to produce ATP, hydrogen and carbon dioxide. The electron transport chain. The hydrogen atoms produced the Krebs cycle enter this chain that are passed along the chain of electron carriers, eventually combining with oxygen to form ATP and water. Therefore, in order to exercise, we must break down energy stored in our body and turn it into ATP.